And thank you for joining us today for addressing the 8 key pain points of Kubernetes cluster management. My name is Raleigh Gould, and I'll be the moderator for today's event. Our featured speakers are Torsten Volk, Managing Research Director at Enterprise Management Associates, and Pete Cruz, Manager, Product and Technical Marketing at Red Hat. With over 15 years of enterprise IT experience, Torsten helps end users and vendors leverage the opportunities presented by today's hybrid cloud and software-defined infrastructure environments in combination with advanced machine learning. Pete has over 28+ years of experience in network, server, application, cloud, and service level management. At Red Hat, he is responsible for leading product and technical marketing for advanced cluster management in the Red Hat Management Business Unit. And before I turn things over to today's featured speakers, I wanted the audience to know that Torsten and Pete will be concluding today's presentation by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA later today with resources from today's event. So I hope you will check that out. And now I'd like to go ahead and turn things over to our first featured speaker, Torsten Volk. Torsten?
Thanks, Raleigh. Yeah, I promise we'll make this a conversation. This shouldn't be me monologuing through my analyst slides, but what I'm trying to do here is to really show the practical relevance of multi-cluster management and these 8 pain points or these 8 challenges that really everybody at some point will come across. And that point is often sooner than later when we look at production deployment. So the agenda here reflects that we are going to start with a hybrid and multi-cloud and what this looks like today, adoption patterns very briefly, and jump into Kubernetes and take a look at how we match the application workloads to the infrastructure. And then Pete and I will discuss the 8 challenges that I was referring to a moment ago. And finally, we look at the Red Hat Advanced Cluster Manager in the context of helping solve those multi-cluster problems. Pete, did I forget anything here?
No, I think you covered it pretty well.
And I always like to jump in a little bit of a provocative slide here. And what we are seeing here is actually quite interesting because this is based on 29,500 something questions and comments on the Stack Overflow developer forum that are all related to either AWS, Google Cloud Platform, or Azure. So the clustering that you can see here was done exclusively by a, you can call it machine learning algorithm if you want, but really maybe it doesn't quite deserve that name. It's a very basic topic clustering that we've done here. And the interesting thing that we are seeing, Pete, and I'm going to ask you about what you guys are seeing in the field as well. But the interesting thing is we see a couple of different patterns of how companies adopt multiple clouds. For example, Amazon 3, Lambda, and EC2 are the big landmark services. Pete, I think we're getting a little bit of a background noise from your end. Is that possible? Let me continue. So S3, Lambda and EC2 are the big flagships for AWS. Then for Azure, we see a different angle where we have Azure DevOps, which is basically a DevOps automation, pipeline automation, collaboration thing. And we see PowerShell, Active Directory, and Azure Functions. So this is a lot more in the Windows area. And when we look for Google Cloud Platform, we see there is no actual a large box that shows Google Cloud Platform. That's simply because Google is spread all over this map. And that shows that Google is much more of a platform versus a stack. We can see Firebase has a big square, and Firebase is a mobile application development framework. We see Google Apps Script. We see Google Sheets, a whole bunch of other individual Google services. And that gives us a little bit of an idea for the different angles that people adopt multi-cloud for, right? Some of them say, oh yeah, we need object storage, we use S3, we need resources, we use EC2. Others say we need Windows automation, we use PowerShell. But then there is different considerations where we have a Python project, right? We start with Python and then we look at the different options that we have from AWS and from Azure, and we pick maybe one or two from each and let the individual teams make some choices. And all of a sudden we end up with a quite varied landscape, Pete. Is that what you're observing as well? And you are multi-deployment at Red Hat?
Yeah, I'd agree. I mean, I think the thing that stands out to me about this slide is that, there is definitely there are definitely many ways to solve a problem, right? And the diversity in this slide and the diversity in our customer base, it's definitely relevant, right? What developers and our customers navigate towards for services and technologies that help solve their problems. No two customers are alike, and I think this slide screams that point.
And the slide is even more fun when you see it live, and you can roll over and you can really drill into it. And to give people a little bit of an idea of what we are dealing with here in terms of multi-cloud complexity, I just slapped this label on here, right? Usually I don't like it when people just say, 80% more complex, right? What is complex between 2018 and 2020? So complex in this case, I want to make that very transparent. It's really the application stack. So what are the technologies that belong to an individual application? And in 2018, we saw 11,762 combinations of Stack Overflow tags in Q2 2018. Combinations of tags are, for example, Lambda plus EC2 plus AWS IAM. So whenever there's a combination of technologies going into a stack, we recorded in those 11,762. And in 2020, this number jumped up to 21,155. So the number of technologies involved in an application stack that originate from one or more clouds has tremendously increased. I think that's what you mentioned in your previous remark as well.
Yeah, exactly. It's that and for an organization to handle on that, it really adds to the complexity within their own environment.
I threw this slide in, Pete. You haven't even seen this yet, but I was wondering, how can you make this a little bit clearer what that means? How an application stack is formed, right? What do people really do in real life versus us analysts or you vendors are talking about? And this is an automatic topic modeling algorithm, quite a simple market basket analysis algorithm. You can see the metrics here for the algorithm if you're a little bit familiar with that. But what we've done is we let it loose on those 29,000 something application stacks, and we let it cluster which technologies people are using together. And what it does is it just places the ones that are related to, it places closer to each other, and the closer they are related to each other, the bigger the bubble gets. So we can see here Fargate and Docker. Fargate, which is Amazon's Kubernetes managed Kubernetes, where all the server nodes are managed. Closely correlated with Docker, closely correlated with Elastic Beanstalk. I apologize, it's a little bit overlaid, but this is an automatic process, so we can't really move that anymore. But it's like throw a bunch of dice and they fall based on the probabilities that we see in real life. And down there we see for Azure the closely related concepts: PowerShell, Azure PowerShell together with Active Directory, and Azure DevOps with Azure pipelines, and YAML release pipelines. And here I just printed it out, Pete, as well for for machine learning, people are always interested in what is everybody using in learning. You can see here the popular technologies and how they relate. It's all evolving around Python on the one end and Keras on the other. Deep learning is what that says down there. So those are popular application stacks, but at the end of the day, individual customers will pick one or the other. They will not use all of those technologies. They will pick them and source them from different clouds. And this is a quick overview here before we jump into the multi-cluster part of things. This is a quick overview of in Q2 this year. Q2 2020 is when this data is from. Oh, here's the right number, 29,965, right? Google Firestore and Firebase were the two most popular cloud technologies on Google Cloud Platform, which is quite interesting, even ahead of S3. Rolly, I hear some chairs and things in the background. I don't know where this is coming from. So we see S3, we see Azure DevOps, we've seen those before. One of the most popular services, and you see the services are colored by the clouds they are from. So blue is AWS, orange is Azure, and green is Google Cloud. And it's interesting; they're quite well balanced. So people really like to pick and choose certain things from certain clouds. Pete, I assume you see that too, right? There's teams that have their favorite thing, their favorite cloud, and they just want to use that, and sometimes even irrationally force fit that into projects.
Yeah, so it's familiarity and the tools that they're used to using, whether they used them in a previous job or a previous organization, right? And that's when you start to see the tools manifest around a particular cloud provider and what they're doing for their particular project. And that it'd be interesting to understand if this is organizational or team, right? So we see even some of our customers, different app dev teams within an organization might use different clouds, different services based on the team and what they're comfortable with.
Yes, that's what we're seeing too. That happens all the time, and sometimes it's even within the same team. Certain people feel more comfortable with DynamoDB versus with the Azure database stack, with Cosmos, and we see more and more even multiple different clouds involved in one project. And theoretically, that should be no problem because microservices are all about that, right? That's why we're talking about service mesh microservices and creating those applications in a cloud native manner. And this is the final slide on this topic where we've just clustered how everything rolls up. So if you think back to the previous slides, this slide basically shows which cloud is the most popular for what use case. So orange is this orange? Yeah, kind of orange or pink or whatever that color is Azure. Then we see Windows is a big part of Azure, obviously, and IoT and database. And then we move down to Google. We see Google is the only one, not the only one. They both have machine learning in here, but Google is biggest for machine learning. Not surprising, analytics and machine learning together make up a quite big chunk. And AWS, yeah, as we saw before, big on serverless, big on S3 storage, big on infrastructure as a service. So at the individual level, a lot of people equate those clouds with their biggest services, and they are trying to push and use them for exactly those purposes. Obviously, Azure and Windows is a great example, Active Directory. So then I couldn't help but put this slide in here. In 2014, Kubernetes came along, and this is this brilliant site called Wayback Machine. You can spend evenings going to Wayback Machine and travel back in time and see what websites look like in in the stone and iron and bronze age of the World Wide Web. And we traveled back to basically the beginning of when the first website got thrown online for Kubernetes. And here was the slogan, right? I put that yellow circle around it, so that wasn't there at the time. But manage a cluster of Linux containers as a single system to accelerate dev and simplify ops. So long story short, we are we are giving something to dev to easily deploy, and we are giving something to ops to easily manage. And at the end of the day, we don't have a problem, Pete, right? I mean, that looks like Kubernetes solved it all.
Yeah, I think, the original intent, right? Exactly, right? How do I orchestrate the services I need to make my application work, and provide some resiliency in that environment?
Yeah, and this is also from the original side, and I think they may still have this photo up there. I forget, but there is what I underlined here. The central set of placement and management policies is what Kubernetes really offers, right? But Kubernetes only offers that as long as you are in one cluster. And initially, and I don't know, Pete, if Red Hat propagated that as well, but there were other vendors around Kubernetes and around Docker containers that would tell you, oh, all you need is one container cluster, and you use namespaces for everything else, and you stretch that cluster between clouds. And if we could have managed to do that, then we wouldn't have any multi-cluster management problems, right? It would just be here the workloads go in, and then it schedules it to nodes, right?
Yeah, exactly. I think it was a good starting point. I will put it that way.
And so I kind of went on the nostalgic train when I built this, because those charts here, they are stolen from the original, from Google I/O in 2014, from the original presentation of Kubernetes. And even those clip arts, right? They were Brennan Burns and I forget who did it with Brennan Burns. But they used exactly these slides here. I just put all 4 of them on one. But what this shows is it's really unlocking those 50% of time that developers are spending on non-development tasks, on worrying about infrastructure, writing another format of YAML and JSON, and debugging why something isn't running, but it's running on their laptop, and why something isn't scaling, and why something isn't secure, why somebody had access to a certain thing but didn't have access to it in the staging, versus the production environment. So all of those things should be taken away from developers, so that instead of 50%, you can have 100% productive, well, not 100, but maybe 70, 80, 90% productive time. And all of a sudden you can get a lot more done as a developer, right?
Yeah, I think, as soon as developers felt that they were, more of their time was spent caring and feeding for the platform and not developing, is when they engaged with the operations team to say, or DevOps or the SRE teams, can you take this over so we can get back to coding?
Yeah. And we'll get to that because it's quite interesting, right? It's so easy to just run a Docker container or deploy your application and move it to a pod, but then there's so many other things that's around this, and those are the things that in the end come to get you. And here, this chart shows the top 10 projects by GitHub Stars, and GitHub Stars is just a popular measure of popularity with developers of an open source technology, right? And what we've done is here we plotted the top 10 most popular projects around Kubernetes, including Kubernetes itself, obviously, which is that brown layer that you see in the middle, the largest layer, the largest chunk. But altogether, this is a very interesting slope. Pete, I don't know if you've ever observed that kind of an increase. If you look back to April 2018, we were at very few stars, right? Maybe 8,000. I think I wrote 8,000 because, I can see that in the system. But we were under 10,000 stars. And by today, with those top 10 pieces, we are at 175,000. Maybe TensorFlow grew similarly. I don't know.
It follows the adoption, right? It follows the adoption of Kubernetes production, Kubernetes for production workloads, and a lot of these projects are, helping organizations move to production, right? Istio and Prometheus for visibility, and et cetera. So I think it's something that you would expect to see with that kind of growth, and as organizations move out of dev into production, those types of projects that you see on the list, right? Those are critical path for a lot of that activity.
Yeah, and the interesting thing about this is there is a lot of choice in the Kubernetes environment. So for example, Grafana, right? Grafana is not the only dashboarding tool that can show metrics and tracing for Kubernetes. There's a whole bunch more. You'll see them on the next slide, and the people get a lot of choice. And the more choice you get, the more different stacks you see. And if those different stacks are disconnected from each other, meaning no centralized control and management plane, that's when you get into the trouble. Because the interesting piece about Kubernetes was from the beginning, and this chart here is from the Kubernetes IO manual. When you go online and go to the manual and go to policy, I believe is the submenu, you'll see this chart. And the key piece here was the declarative object configuration thing, where you basically just put all of your configuration files into one directory, a structure, or into one directory. I'm not entirely sure, but you store them all centrally. That's the point. And they know the state, the desired state, or the intent that you are having of what should happen with your application and with the Kubernetes cluster and with everything around it. And that's how the Kubernetes scheduler knows what it needs to do when something goes wrong, or when something needs to be scaled up or down, or an application makes a request for a certain thing. That declarative aspect is really the key, and that's what's great about Kubernetes. The problem is, Pete, what came next, and I know you have the next slide here after this one. I got that top chart here when I just looked up Entropy on Google search, image search. It's just I think Wikimedia chart on Entropy. Very simple how it shows it, but that's exactly what's happening in the Kubernetes environment. If we just had one cluster and we could use declarative management for that cluster, things would be fairly easy. Not entirely, because there's still there's still aspects to the stack that are not under the control of Kubernetes. But it would certainly be a lot more of a unified approach. But in reality, we find that different clouds like EKS and Fargate and AKS, and there's tons of different clouds out there that offer Kubernetes in a managed, semi-managed, or a totally manual manner. Like the most popular one is still Amazon ECS, where you don't really get all that much of a benefit in terms of management, and you certainly don't get any cost benefits, right? You're responsible for your own scaling and for your own management of that whole Kubernetes stack. So people like to use managed clusters, but then they use managed clusters, and they're not managed together with the other clusters that they already have. And then that same organization has also, maybe clusters managed based on OpenShift or based on, something CERD. And that's when you run into those issues. And the reasons for that are, there's a lot of them, really. Regulatory compliance is another one where it's, I said that before, you could just use namespaces. That's what they were originally made for. But then you're not entirely sure if that's really compliant, because you're not sure if the storage that is used, or even the memory that is used, is truly separate, or can you confirm, can you prove that it was separate, right, when you need to do the audit? So you think, nah, that's too risky, let's just spin up another separate cluster. That way the audit is at least easier, right? We have a separate audit report for all of that, and we're good. And another thing is the stretching of clusters has showed customers really don't stretch clusters between locations or between clouds. They just stand up separate clusters, and then they deal with the moving of the applications in a different way. Specific applications require a specific type of cluster, or at least ask for a specific type of Kubernetes cluster with a specific configuration, maybe GPUs, maybe something else in the operating system. So there's a lot of reasons why people started using multiple clusters. And the moment you start using multiple clusters, you have very quickly you have a bit of a mess in terms of all the configuration that you can do to those clusters. Pete, you have your own slide. That means you feel very strong about that point.
Yeah, even if you look at it, the basic, right, a development or a QE or a production cluster, they have different requirements, different policies depending on what the application are. So typically those end up becoming the first set of clusters within the team. But organizations, they quickly realize, you look at edge use cases as an example, right? I've got to reduce latency out to the edge, so I need to have those applications and the clusters closer to the users. I might have the geopolitical or regulatory data sovereignty rules that I need to place clusters into a particular environment where maybe the application lives somewhere else. Disaster recovery is big, so I might have clusters in my private cloud, but I want to be able to leverage a similar cluster in the case of, for example, OpenShift. If I'm running OpenShift on premises and I'm using AWS, I can run OpenShift clusters in AWS, and I'd be able to do that for disaster recovery or for scale out use cases and those type of things. So the key challenge here is there's many reasons for deploying more than just one cluster. Very, very purpose centric.
Yeah. And I mean, what I often see personally, and people do, and even parts of my team used to do, is you just deploy a cluster when you do with your CI/CD, right? After the build, you automatically deploy it on a new cluster, and you define the cluster in the software, and then maybe you do that for testing, for using external testing groups or internal testing groups too, right? So that they have enough capacity. And afterwards, you destroy that cluster again if you automate it and program it properly, or you end up with a whole bunch of separate clusters with no centralized management. And it's almost that proliferation of clusters that are here the issue. And this visualizes it, this chart, and this is interesting. This is not based on marketing material. This is based on reality, right? It's the same 29,650 something real developer questions and problems and comments that we captured on stackoverflow.com are clustered together here specifically for Kubernetes and the 3 individual clouds. So this cluster here is all the different technologies that are involved in Google and Kubernetes. So you see the sub items are the smaller ones, the main items are the larger ones, and the biggest item is Google Kubernetes Engine, which is the dominating Kubernetes service at Google here. So that's the highest level. But here at the lower level, you see Stackdriver, and it has Google Container OS. It has it has a whole bunch of technologies underneath. The same is true with Helm for Google. You look at autoscaling, you look at Istio here, and we did that for all the 3 different clouds just to show that this even the stacks are entirely different if you're on those clouds, even though they all advertise that they stick to upstream Kubernetes, right? We provide everything that runs on upstream Kubernetes runs on AWS Fargate or on AWS EKS or on AKS or on Google Kubernetes Engine, right? Because they're all upstream clouds. But what you need to then remember is that there's a lot of other things that belong to that whole stack that are unique to Azure and unique to AWS and unique to Google. And those are the things that are then problematic. And even at AWS, you have Fargate, you have EKS, and it was quite funny. At the last reInvent, Amazon announced the compatibility of AWS and Fargate, where my first reaction was, oh man, I always assumed they were compatible. What does that even mean? And then I dug into it and I saw, you couldn't actually just exchange worker nodes between EKS and Fargate, but now you can, right? But there's a whole bunch of other things that you can't. And that's what we're really talking about today, Pete. And that's what this slide shows. This is the entire stack, and that Kubernetes needs. I mean, it doesn't really need, I guess in production, it almost needs all of those individual parts. I guess if you don't want to do CI/CD, you don't have to, right? But all of those are component categories that an enterprise application stack typically has, that we are seeing out there in the wild. And each one of those boxes has a whole bunch of individual components that you can choose from, right? And funnily enough, Kubernetes is only one of them, and it's under scheduling and orchestration, under the orchestration and management main category in yellow at the bottom right? That's Kubernetes. But then there's a whole bunch of other stuff here that you see that is outside of Kubernetes, and that you have to keep under control and have to keep consistent between applications that run on Kubernetes when you do your operations management, so that when, for example, one team deploys Kubernetes based on specific code, right? Ideally, they define all of the deployment as code, including the cluster structure and the monitoring requirements and how the key management is done, and all of those boxes defined as code. But even if you do that, if you don't manage that code centrally, then you have a very small chance of that all being consistent in your organization, Pete. And I think that's what your slide is about as well.
Yeah, as you start looking at, the management challenges increase as organizations start to deploy, more clusters, going from the development, even in a single cluster, right? You want to be able to manage, you mentioned it earlier on the policy and the configuration side. How do I ensure that I don't have, cluster configuration drift, right? We set it up and deployed it in a certain way, multiple developers accessing it, they could potentially make adjustments or changes that could potentially impact another application. So how do I ensure that that's there? How do I ensure that the app, I get from app deployment, from development to production, start to go out into multiple development teams, whether it's dev, test, or production, and ensuring that I have cluster consistent provisioning, right? How do I consistently and reliably deploy clusters that fit the purpose that what they're intended to do? And then how do I enforce those policies across all of those different clusters? And when I have issues, how can I quickly find the resources that are supporting it and modify those resources across all of those clusters in a consistent way? And we get to what we call distributed multi-cluster, and that's really like that hybrid multi-cloud. I've got on-premises based environments and public cloud environments for certain particular purposes. How do I centralize that and get a single view of my entire fleet, right? And then when I start deploying applications and distributing it, how can I do that at scale? Make sure that when those clusters get provisioned, that I'm actually putting the right services and the right applications, like you showed in previous slides. All of the services that development team needs, whenever the clusters go out for that team, they need to have these services available to them so they can continue to do the development work without having to worry about, is it there or not? And you also brought up the auditing compliance, right? What was deployed? When was it deployed? What was configured? What was changed? Is it change compliant? How do I remediate and address that violation, say whether it's a policy or it's actual industry standard? Right? How do I fix that when I see it? So those are all fundamental challenges of, in my years in management, right? Anytime you start to grow in complexity and scale, right? Management becomes extremely important to be able to get to accelerate and scale those environments.
And that, Pete, that gets really interesting. We've talked about a couple of examples of horror stories, and I kind of enjoy reading those horror stories where you basically do a postmortem of why your Kubernetes cluster failed or why an application failed. And it is often those unintended consequences of a great idea that somebody had to circumvent something that was perceived to be a limitation of Kubernetes, right? But then it turned out to be a feature, and it's great because you don't want to be too rigid, but you don't also want to let people do things that are just they will kill compliance, and then you have to justify to your boss why your team did this. It's
it's the whenever you've got individuals doing things themselves, right, for the team, there's always the opportunity for variance, right? Nomenclature, capitalization, non-capitalization, structure. I like it done this way. Somebody else likes it done another way. And if you do it from an operational perspective and you have no record of how it was deployed, it becomes even more problematic.
Yes, and this is a transition to this slide here. And I calculated that number, how many permutations you get in total when, the way you just do that is you take the number of products, they call it products. Those are the CNCF categories here. So the number of products in each of those categories, when you multiply them, so you multiply, I don't know how many monitoring products are in there, quite a few. You multiply that with the application definition and image build. Then you multiply it with the next one, the next one, the next one. And you arrive at an unbelievable number of permutations. And those permutations are similar to what I said about tag combinations on Stack Overflow, where you have a choice to make every time. And sometimes you have multiple choices to make, right? With monitoring, you have to make a choice what kind of agents you are deploying. You have to make a choice what you're using for tracing versus for metrics monitoring versus for streaming data monitoring, maybe for different aspects of monitoring. And you have to make those choices in all of those different categories, and making that visible and making that transparent so that you can actually control it, so that you don't have pockets of technologies in one area that are coming to kill you later because the policies that you have defined are not really synced between, say, Ansible and Terraform and Chef Infra, because you have all the three of them in there. That is, I think, a huge challenge with this. And Pete, you came up with those personas, right, where you're really looking at this whole management problematic from the angle of a very specific set of people in the enterprise.
Yeah, so the customers that we're engaged with, right? I mean, from an operations perspective, they're really trying to get a simple view across their fleet, right? They've got many deployed across multiple clouds or multiple environments. So how do they see their biggest challenges, right? How do they see cluster health? How do they understand the impact that it may have on the applications that are running on those clusters? How do they visualize that? How do they automate the provisioning or even the deprovisioning of clusters environments? And the DevOps SREs that are really trying to support those development teams, how do they manage the lifecycle of those clusters regardless of where they live, right? You had a slide earlier, right? It's many APIs, the new silo, right? So one of the things that we're trying to do with the Red Hat Advanced Cluster Management for Kubernetes is provide that view, right? I can see all of the clusters that I have, whether they are OpenShift on premises or OpenShift in the cloud, or even native public cloud Kubernetes distribution, to centrally create and update and delete those clusters across the environments, to be able to search and find and modify any of the resources across the entire domain, and even have quick dashboards and views to resolve issues in a federated domain. So all of this really ties together to say, what do I have? Where is it? What's it running? How big is it? What's being consumed by what resources are being consumed? Is all being able to centralize that in a globally distributed, multi-cluster distributed way is extremely important for our customers.
Yeah, that ability to create search-based views is really interesting across clusters, where you can really check, okay, so what are the policies that are applied, and even what policy types are people using? Are they maybe doing imperative policies versus declarative? Are they using files that are separated? And you can see your status quo, and you can see what you need to do to get to a point where it's more scalable, and where when you get an audit, and that leads me to compliance, right? When you get an audit, you get it consistently. And for this presentation, I went back to the Kubernetes documentation again and looked at this is the Gardener project, the SAP one, where you basically can specify compliance policies independently across clusters, and you have to define event types, you have to define user types, you have a ton of different parameters that you can actually define. But at the end of the day, you need something that ties that together. And Pete, as you said, that gives you visibility on the one hand, and also the ability to enforce all of that, or if not automatically, then maybe semi-automatically, with an added button push and an alert to enforce all that. So even if you're covering all of that as code, you still need to be able to centrally manage that code and output it for the auditor, and also output it for yourself internally, so that you're seeing what you're doing, with your customer data, with your role stack, with all of those different points. And this is just a couple of examples, but you're literally in a production environment write dozens of pages of those policies for a single environment, right? So there's absolutely no way that you can get them consistent.
Yeah, and you could do that, and you could build hundreds of files for a cluster, right? And think about trying to make sure that I've got multiple clusters across, distributed geographically, right? And how do I make sure that those same policies are consistently up to date and manifested across all of those clusters? It becomes near impossible.
And when that gets even more interesting is when you do it on a managed KS, for example, managed Kubernetes, or even Fargate, and on the one hand, and then you do it maybe on CS, which is not managed at all, really, or you do it on AKS. And those policies have to really cover the same compliance rules and controls. They should be cloud independent, right? But at the end of the day, there have to be humans going in there and making sure that one cloud supports the same thing as the other, and in a lot of cases, it doesn't. So the monitoring API is different, or all the IAM API. I mean, you've seen the stack before. There's tons and tons of different APIs that you need to talk to, and there's only one way of doing that, and that is really applying the GitOps idea and doing it centrally, and just check in, check out, like a GitOps server, basically. And this leads me to the policy management piece that is going beyond just the compliance. It shows all the configuration steps that you have to go through. This is also from the Kubernetes documentation, where you can simply see all of the individual deployment steps all the systems you have to interact with, and you can write to, here you see the CRDs, you can write to all of those different things. And if you write to all of those separately, and one team creates their own configuration files for the instrumentation of the machine controller provisioning, the workers, or of any of those deployment steps, then you are going to get into a lot of trouble, even between dev, test, staging, production environments. Pete, you want to follow up on this from the persona perspective, and especially putting the security persona in there continuously, right? Where it's just once when she gets pale and faints when she sees what you've.
Yeah, the security ops, or even the DevSecOps, right? The folks that are tasked with managing those policies, right? How do they ensure that all of the clusters, and again, go back to the purpose, right? Is this a disaster recovery? Is this a PCI compliant cluster, right? Or running a PCI application, right? How are they compliant? Are they standard? How do they set the consistent policies across diverse environments? So if I'm running, like you said, across multiple clouds, and then how do they get alerted and notified when there is drift, right? Somebody does make a change locally to a cluster, right? How do I pick that up immediately and either inform you that it happened, or even remediate it because it's a critical policy, right? And from an operations perspective, it's not just the compliance stuff, right? It's the policies, right? How do the best way to ensure that I've got uptime is to ensure that I have consistency in the deployment of my clusters, right? Whether it's at the infrastructure level, at the application level, or at the service level, right? And ultimately, it becomes critical to do that in a centralized way.
And this is the interesting thing, right? Because in the ideal world, and you tell me if people are actually doing that with your tool here, but in the ideal world, the security person is not requesting a bunch of PDFs and a bunch of Excel sheets for compliance, right? In the ideal world, it has a persona, and the system logs in, sees it, prints out her compliance report. So that's how it should be.
Exactly right. I need to show that I've defined policies. I need to show that they're being monitored, and I need to show that I can enforce them if they're in violation, right? So, yeah, so advanced cluster management, our advanced cluster management provides that centralized way to define those. It's all in YAML, so it supports a GitOps-based approach. So even if I'm defining policies, I can automatically pick them up, but I can define them and attach them to those purposes, or what we call labels. So I could have a certain set of a policy for all of my AWS clusters because there's some bit of difference because they're running on AWS, but again, it's a standard policy. And those policies and compliance rules could be across applications, could be for security pieces, namespaces, role-based access, et cetera. It could be on the infrastructure, right? How do I, maximum size and those type of things. So namespaces, et cetera. So how do I put those in place? And then whenever cluster gets provisioned, right? It's labeled with its purpose. It will automatically be mapped up against those policies and then configured in the appropriate way consistently. And then again, as you mentioned, being able to view across that environment. We provide a number of out-of-the-box policies for, NIST policies for Kubernetes, PCI, HIPAA. And we continue to add additional out-of-the-box type clusters, but the users can build in. It's all in YAML. They can build in their own policies and then have those policies enforced, either enforced or just informed, right? And trigger events to say, hey, you need to take a look at this. Do you want to change it? And then execute a configuration change or set it up for a maintenance window or whatever, depending on the policy.
And you don't need to go declarative in one go, right? This works just as well for file-based object declaration that's implemented.
Yep. Yeah. Anything that you can access, read through, through the Kubernetes APIs can be built into a policy.
Yeah. Policy as code.
Yep. Exactly.
Application management. Operate traditional applications in microservices-based applications side by side. Maybe even Microsoft, Windows and Linux containers, separate topics though. But here we see, Pete, this is a topic for years that has fascinated us, and we have been wondering, is this ready for production? Can we really launch virtual machines in a pod, right, and run it, and the kubelet manages that pod just like if it was a container pod, and I can then migrate my existing legacy applications or just enterprise applications, right? I may not want to modernize everything. I may not want to change anything about some of those things, right? But for them to interface with my modernized applications and with my new applications, they need to be on the scheduler, right? Otherwise, the Kubernetes scheduler may just move the containers somewhere, and my traditional app won't have any access anymore, any data access anymore, or may cost a ton of money to reestablish connections. So you guys have made that a production thing now that I can run VMs and containers as pods on a cluster, right?
Yeah, so with OpenShift, 4 to 5, the OpenShift virtualization, the use case is really about those hybrid applications, right? As organizations are moving to building cloud native components or microservice, they still have components of an overall application that are virtualized. So they want to include that, like you said, in that deployment. Mm-hmm. I think what we're not really seeing is people trying to take Kubernetes to manage purely virtualized workloads, right? I mean, those are the traditional virtualization. They're trying to encompass and do that. It's really bringing those applications into that hybrid mode, right? That hybrid mode of virtual components. Maybe it's a backend database is still running on a virtual machine, and then all of the app components are running in container, a microservice-based architecture from a container perspective. That's really where we're seeing the bulk of those use cases come in.
Yeah. And as you said here on the slide, I'm just seeing this, that the SRE now sees the relationships and can manage it all in one single pane of glass, right? That's where you are going here.
Yeah, exactly. So what application? So I might have an application that's running across, multiple clusters, right? How do I quickly see this particular, my guestbook application, and which clusters is it actually running on? What resources are supporting, and what is the state of those resources, and how are they contributing to, the application's health, right? To be able to quickly view that. It's also about deploying them, right? How do I ensure that when I'm deploying new clusters, right, given its purpose, that must have these particular applications on it because it's part of that environment? How do I make sure that I can consistently do that in an automated way?
Yeah, yeah. This is an interesting topic. On here, you have the application dependency map.
Yeah. So you can see here, right, what applications and subscriptions. So subscriptions are really what's the repository where the bits, for that application, the images, et cetera, and the resources live, right? Is it in a GitOps repository? Is it in a Helm repository? Is it an object store? Right? What are my placement rules? So that defines, given the purpose of a given cluster or the labels that I've assigned, which applications go where. And I can quickly see, which clusters, this particular application is deployed on 3 clusters. It's got, a number of services and deployables associated with it. And what actual nodes or worker nodes is that application actually running on within those clusters. So I can easily deploy applications to scale. We can, deploy them from multiple sources. So I might have multiple repositories that are contributing to those environments, or if it's multiple development teams that are using their own repository, and then provide that visibility. Again, once, as they're deployed, where is it, how's it running, and what's the state of those deployments?
It's a fact if my TensorFlow deep learning application needs GPU or a certain number of GPUs or a certain brand of GPUs. As a developer, all I have to do is set that as a flag, and the Kubernetes policy will just go in where it can.
Exactly. Yeah, you define what the application requires and what it needs and where it's going to get it, and the system will pick that up and automatically deploy when clusters are deployed that match those. And I can even change labels to existing clusters and say, this is now my disaster recovery one. Make sure that the applications go out there, and it'll automatically deploy once those flags are set.
Yeah, and this is actually interesting. That plays right into the cost topic, where we see this GPU thing where you can spend a lot of money on training models, machine learning models, deep learning models, and you think, "Ooh, I got a really good deal. I did it on, XYZ public cloud." But in reality, it was a horrible deal, because you could have scheduled it for your local GPUs that were just doing nothing. They may be looking too expensive, but they were just not busy, right? And you could just go and use those. And this whole billing topic has been with us, at EMA as an analyst firm for years, because you see, I remember, and I think it's still the case, Pete, right? You see hundreds of accounts for Amazon in a larger organization, and for Azure. Maybe for Azure it's a bit more consolidated because it's enterprise agreements, but you still see dozens sometimes of Azure accounts and of Google Cloud accounts, and they're often really not even linked and consolidated in any way. And now when we have containers and Kubernetes containers, and everybody says, you can just run your microservices here, just bring them and we bring the rest, and people do that. The cost accounting aspect is getting a real nightmare, because all of a sudden, my microservice may consume something that's really GPU intensive or disk intensive or something, but you may not be counting that as more as a couple of IP hits against that microservice, but you don't even know how much money I'm costing you. That's another interesting aspect, right?
Yeah, absolutely. We've embedded or entitled a cost management solution with OpenShift, right? That basically provides that visibility of resource consumption from a container and what it's consuming underneath. So I can view the costs on a project basis. I can view it from a cluster basis. I can also understand if I'm, for example, running OpenShift on AWS, how is that that Kubernetes environment contributing to the overall cost of my Amazon bill, right? And really giving you the trends. Is it going up? Is it going down? Am I seeing some projects going, increasing significantly, much more than we expected, right? Because it's all about planning and making sure that you're putting things in the right places based on performance, based on capacity, based on cost, right? Cost should always be part of that decision process.
Yeah. So unified automated cost management.
Exactly.
There's literally no alternative anymore to that in a Kubernetes multi-cluster environment. Otherwise, your cost accounting will just be off significantly. And we need to speed that up a little bit. I know we have a hard stop in 5.5 minutes. So I have 2 more slides here. So the collaboration aspect of things, this is actually also interesting when we look at self-service and collaboration, and we need to do a central code base, here in the middle, and this is actually totally coincidentally, the IBM Cloud service. I'm not kidding. I had used that for an article that I wrote in the past. And the interesting piece was the message of this is you have a centralized set of service mesh policies, of configuration and control policies, of firewall policies on the one hand. The app ops team have set that, the IT operations guys. And on the other side, you see the developers that are consuming this stuff, these microservices, or could be infrastructure resources, could be anything. And you want to be able to have the developers really access that centrally through one API, and that sums up the next slide on developer self-service as well. But both teams, IT operations and developers here, collaborate, and they both work on that in the middle, on that piece here, where they're jointly defining those deployment targets, those services, those policies, everything that belongs together. And if you then let the developers automatically only access everything through API and CLI, obviously, I guess UI as well, but I think the biggest piece is API, then you really lock all of this down to a significant degree, and you get a lot more consistency than you would have otherwise. And you get the self-service paradigm implemented. And Pete, this is I believe my last slide before the summary slide here. We have we define centrally this desired state, right? For all of those different components, we define that declaratively, ideally, and then we keep observing after deployment if it's still the same, and if it's not, we make a decision if we want to roll back that configuration drift, or if we want to flag it, or maybe we'll change our policies or do something else with it. So Pete, I'll let you summarize and talk about briefly the advanced cluster management for Kubernetes, simply because we have 2.5 minutes left. So yep. I'll give you my slide and let you know when I should.
Sure. Yeah. So I think, in summarization, right? I mean, all of the things that we talked about, as soon as you start to move to multi-cluster, it's really about managing it and controlling it, understanding what you have. We're past the point of being able to manage every cluster independently, in and of itself, right? It's just not feasible, especially as you grow as an organization. So really, it's again, it's the unified visibility across the board. How do I have a centralized way to manage both the cluster lifecycle, the policy, the policy and the governance that I have, and even advanced application deployment. And to touch on that previous slide, from a GitOps approach. So everything that we're doing with advanced cluster management supports a GitOps model where developers can commit their code, that the teams that are collaborating can commit their policies into the Git. The system can pick those policies up and enforce and check the environment and make sure that things are consistent, and you can use that as your proven place of record as we kind of get back, right? Lifecycle, policy, and application deployment as code is really kind of where we're driving at.
Yeah, and we're doing that.
So these are the fundamentally 3
levels.
Yep. Yeah, exactly. And being able to do that consistently across environments is really and critical, right? Not just, I'm using one type of Kubernetes distribution, right? I might have multiple, and I need a consistent way to do it across all of those different environments.
Right. So at the end of the day, Rolly, I'll pass this back to you. Thank you, Pete. This was a great discussion. I really enjoyed this. And you had a couple of housekeeping follow-ups here.
Thank you, Torsten. Thank you, Pete. Before I conclude today's event, I wanted to remind the audience that you will be receiving a follow-up email that will include resources from today's event. I had several people ask about the slide presentation. Yes, that will be part of the follow-up email, so I hope you'll check that out. Some of you had questions we were unable to get to. I will be sure to send those on to the speakers so they can get those answered for you. Thank you all for joining us today, and I hope we'll see you at a future EMA webinar. Thank you, and enjoy the rest of your day.
Thank you, everyone.